Hi, this is Jeline from the Honors Tutorial, and welcome to the part 2 of Laws of Exponents for Division. This is under Mathematics 7. So we have here the distinctions for the laws of exponents for division. The first one is if m is greater than n, we are referring to the exponent that we have here, this and this exponent. If m is greater than n, then this will be our solution. A raised to m minus n. We have to subtract the exponents if m is greater than n, or the exponent of the numerator is greater than the exponent of the denominator. Next, for the second one, we have here a raised to m over a raised to n. So the second one refers to when m is less than n. It is when the exponent of the numerator is less than the exponent of the denominator. So therefore, our solution will be this. We have to change that into a fraction because if the exponent of a is less than the exponent of the denominator, then it will become a negative number. And we don't want that, a negative exponent, right? So therefore, we have to do something to make it a positive number. How? By changing it into a fraction. So just write 1 in the numerator. It is constant, okay? So please don't write any number aside from 1 or else your answer will be incorrect. And then in our denominator, we will write a raised to n minus m. So in this case, if you will apply this, your answer will be a positive number. Next. So for this part, for the third one, so this is if m is equal to n. I will write it for you here. Again, if m is equal to n. There are times that the exponent of the numerator and denominator is the same. So therefore, if that is the case, automatically your answer will become 0. Because we have to subtract, right? And then, for example, 1 minus 1, that's 0. So it is 0. Let's have an example for us to try this. Let's say that we have here h raised to 5 over h raised to 2. So this is what we are going to do. Since the exponent of h is greater than the exponent of the denominator, we have to subtract it. So h raised to 5 minus 2. So h raised to 5 minus 2, it will become h cubed because 5 minus 2 is 3. So that is the answer for number 1. Simple as that. Next, let's have number 2. For number 2, we have here this. Let's say that this is the given. H cubed over h raised to 7. So as you can see here, the numerator, the exponent in our numerator is less than the denominator. So therefore, we have to follow this. Change it into a fraction. So write 1 in your numerator and then write h, your base, and then write 7 first minus 3. So 1 over h raised to 7 minus 3, that's 4. So this is the answer, 1 over h raised to 4. For number 2. Next, let's have number 3. For number 3, this is the given. As you can see in here, we have here same exponents because the exponent of the numerator is 10. The exponent of the denominator is also 10. So therefore, applying the rule here, automatically our answer will become 0. No need to compute. It is 0. Next, we have here number 4. We have to apply the rules that we have here. So that is, let's have a first. So a raised to 2 over a raised to 7. So let me just teach you the shortcut. Okay. So this is how you are going to do this. A raised to 2 over a raised to 7. Subtract the numbers though 2 is less than 7. So 2 minus 7, that's 5. It should be a raised to 5, right? Where would where would I put a raised to 5? You should put it here in our denominator because 7 is greater than 2. That's the concept behind that. Put the difference on the bigger exponent's place. How about this? We have here b and b. That is cancel 0 because the exponent is the same. Let's have c. C raised to 5c cubed, subtract the exponents, 5 minus 3, that's 2, so c squared. Where would I put c raised to 2? On top. It is because 5 is greater than 3. And that's it for number 4. Next, let's have another. Number 5. For number 5, let's have the number first. I want you to think of a number that can divide 18 and 36 at the same time without remainder. You can use 2, yes. 3 also. 9 also, yes, you can use that. And then 18, you can use it. So if you choose 2, obviously your answer will be not in the simplest form yet. Therefore, you have to simplify it for the second time and simplify it again and again and again until you reach the simplest form. So that is the disadvantage of choosing the least number that can divide 18 and 36 at the same time without remainder. So what if you choose 9? Same process. You still need to simplify it again because it will not produce the simplest form unless you use the greatest number that you can use to divide 18 and 36 at the same time without remainder. So let me just use 18 and show it to you. So 18 divided by 18, so that's 1 over 36 divided by 18, that's 2. And that's it. There's no number that can divide 1 and 2 at the same time without remainder. Now we will proceed with a raised to 8 and a raised to 10. As I have mentioned earlier, just subtract it. 8 minus 10, that's a raised to 2. And then decide Are you going to place it in your numerator or denominator? In your denominator. It is because 10 is greater than 8. That is the only reason. So you have here b raised to 2 and b raised to 1. Subtract the exponents. So you have here b or b raised to 1. Where are you going to put b? On top here in your numerator. Why? Because 2 is greater than 1. And that's it. Next, c raised to 11, c raised to 2. Subtract the exponents. So we have here c raised to 9. Where are you going to put c raised to 9? On top again. Why? Because c raised to 11 is bigger than c raised to 2. So now, what are we going to do is to simplify the numerator. What do I mean by simplifying the numerator? Um, we have here 1 beside b, which is the numerical coefficient of it. If it is 1, please don't write it because its purpose is to be invisible when it is placed as a numerical coefficient. So we will write b c raised to 9 over 2a squared, and that's it for example 5. So that's it for part 2 of laws of exponents for division. I hope that you have learned something about it. And this is also the last part of laws of exponents for division. If you have inquiries about us, don't hesitate to message or contact our FB page, The Honors Tutorial. Thank you and God bless. Bye.